Hmm. Okay, sir. Thank you. Next. Excuse me. Dear, I forgot your name. आपका नाम भूल आपका नाम भूल गणेश गणेश छोटा सा मिठाई का बताते हो Yes. Thank you. Okay. Good morning. Sorry. Good afternoon, everyone. So we are discussing about incidents and associations and causation. So let's talk about uh, just a minute. Yeah. So we left somewhere around here. Last time I discussed this association and causation up to some limit, and I left it somewhere around here. So I will start with 21, slide number 21 here. So it's a measures of association, measures of association. So there are different type of measures of association, which is one of them is ratio measures. So ratio measures, it measures the association with relative differences between groups being compared. So there are two different groups which are being compared to each other, and that is a measure of ratio. Okay, and rates are something which is differentiated within the group. Like for example, there is a number of there is a population of Hyderabad, and we want to see how many people, how what percentage of population drink within the Hyderabad. So the number of people who the percentage of people who are drinking will divided by the total number of people residing in Hyderabad. That is rate. Ratio is two different group. Like how many people are drinking in men, how many people are drinking in women. So this, when you compare two different groups, it becomes a ratio measure. Okay. So it is always with a comparative group. Difference measures. A difference measure are measures of association in which absolute differences between groups being compared. So difference measures are measures of association in which absolute differences between groups being compared. Okay. Now absolute differences. So there is absolute differences and relative differences. In absolute differences, it means the main goal is often the absolute reduction in the risk of an undesirable outcome. So absolute differences are the main goal is often to often an absolute reduction in the risk of an undesirable outcome. When outcome is interested, when outcome of interest is continuous, the assessment of mean absolute differences between exposed and unexposed individuals may be an appropriate method for the determination of association. Relative differences are that can be assessed for discrete outcomes and to assess causal association. The relative differences are to be assessed for discrete outcomes and to assess causal association. So there are types of differences. The absolute differences, relative differences we will discuss with there is an example and usual application. So attributive in absolute differences there is an attributable risk which is usually applied in primary prevention impact search of causes, and population attributable risk is primary prevention impact. Efficacy is the impact of intervention on recurrence, case fatality, etc. And the mean differences, which is an outcome of continuous variable, is a search of determinants. Relative differences are of relative risk or rate ratio and relative odds ratio. It is applied for search of causes, and another one is also applied for search of causes, odds ratio. Like relative risk, the formula for relative risk is incidence among exposed divided by incidence among non-exposed. It is direct measure of the strength of association. Right, it's a direct measure of strength of association. So relative risk, usually the relative risk is 1, which states that there is no association. If the relative risk is more than 1, there is a positive association probability, which is probability causal. The relative risk, if it is less than 1, that is negatively associated, which is possibility protective. Now coming to odds ratio, the relative odds, it's also known as relative odds, history of exposed versus, so it can be calculated by 2 by 2 table. On the left hand side, for example, history of exposed and history of not exposed, versus on horizontally cases or controls. So ACBD, I think we know the formula here. The product of, sorry. So the ratio will be between the product of two cells So the ratio will be between product of two cells that supports the hypothesis of an association versus product of two cells that negate the hypothesis of an association, that is AD by BC. Right. Attributable risk. It shows how much of the disease that occurs can be attributed to a certain exposure. It is often used to imply the cause-effect relationship and should be interpreted as a true etiological function only when there is a reasonable certainty of causal connection between exposure and outcomes. When the causality has not been firmly established, then the attributable risk is termed as excess fraction. A population attributable risk. What proportion of the disease incidence in a total population can be attributed to the specific exposure? To know the PAR, we need to know incidence in total population, which is A. For an example, which is A. The incidence of unexposed group, so which consider it as a B. Now population attributable risk is equal to A minus B divided by A. So the formula becomes A minus B divided by A. Now what is cause? The word cause is one of the general use is the one in general usage in connection with matters considered in the study, and it is capable of conveying the notion of the significant effectual relationship between an agent and associated disorder or the disease in the host. Now, types of causal relationship. Types of causal relationship. There can be direct, there can be indirect. So, in direct relationship, there is a factor which can lead to the disease, and in indirect, that there is a factor which can lead to one step, then it leads to second step, and then the disease is formed. If a relationship is causal, four types of causal relationships are possible. One is necessary and sufficient. Second is necessary but not sufficient. Third is sufficient but not necessary. And fourth is neither sufficient nor necessary. So if the relationship is causal, there are four types of causal relationship, which are necessary and sufficient, necessary but not sufficient, sufficient but not necessary, neither sufficient nor necessary. So coming to necessary and sufficient means a factor is both necessary and sufficient for producing a disease. Without the factor, the disease never develops. The factor is never develops, and in the presence of the factor, the disease always develops. If the factor is sufficient. I think it should not be clear. It should be very clear. Necessary and sufficient concept means without the factor, the disease never develops. That means the factor is necessary. And in the presence of the factor, the disease always develops. That is, the factor is sufficient. Now, necessary but not sufficient means each factor is necessary but in itself. Sufficient, each factor is necessary but not in itself sufficient to cause the disease. But Thus, multiple factors are required, often in a specific temporal sequence, to cause the disease. For example, carcinogenesis is considered to be multi-stage process involving both initiation and promotion. For cancer to result, a promoter must act after an initiator has acted. Action of initiator or a promoter will not be produced will not produce the cancer. Now, for example, the whole concept is, if there is some factor which is not sufficiently available it is not sufficient to cause the disease, but it is associated to the disease. We know that. Sometimes we need multiple factors in a composite way so that the disease can occur. Means if there are four factors leading to the same disease, the combined effect of four factors may result in the disease always. For example, the carcinogenesis is considered to be multi-stage process involving both initiation and promotion. For cancer to result, and initiator or promoter alone will not be sufficient for causing the disease. Sorry. Type of causal relationship. Each factor is necessary but not sufficient. Like you have factor A, factor B, factor C. These are all associated to the disease, but they are not sufficient to cause specific disease. So here the composite effect comes from factor A plus factor B plus factor C. Now, coming to sufficient but not necessary. The factor alone can produce the disease, but so can other factors that are acting alone. Thus, either exposure of radiation exposure or benzene exposure can each produce leukemia without the presence of others. Even this situation, however, cancer does not develop in everyone who has experienced radiation or benzene exposure. So, although both the factors are not needed, other cofactors probably are. Thus, the creation of sufficient is rarely met by single factor. Now, types of causal relationships. Each factor is sufficient but not necessary. So, in causing the disease, if factor ABC are available, so each single factor, which is also known as independent risk factors, which in presence of others or not in presence of others, it will still cause the disease alone. Neither sufficient nor necessary. A factor by itself is neither sufficient nor necessary to produce the disease. This is more complex model, which probably most accurately represented the causal relationship that operates in most chronic diseases. Now, types of causal relationships. Each factor is neither sufficient nor necessary. So, in this, there are multiple factors which need support of other factors to create to a person to have a disease. Factor A, B, C is present, but it needs support of many other factors. Maybe or maybe and together. The evidence of causal relationship in 1840 Henle proposed postulates for causation that were explained by Koch in 1880. The Koch's postulate. The Koch postulate for causation were as follows: the organism is always found in the disease. The organism is not found in the with any other disease. The organism isolated from one who are the disease and cultured through several generations produces the disease. And last one, Koch also added that even when the infectious disease cannot be transmitted to animals, the regular and exclusive presence of organism proves a causal relationship between the host. These postulates, though not perfect, uh, proved very useful for infectious diseases. However, as apparently non-infectious disease assumed increasing importance towards the middle of the 20th century, the issue rose as to what would represent strong evidence of causation in the disease that were generally not of the infectious origin. The US Surgeon General appointed an expert committee to review the evidence. The committee developed a set of guidelines which is available on this reference, which have been revised over the years. Now, criteria for causal association are surgeon so in 1964-65 he created it. Okay. So criteria for causal association are consistency, strength, dose response, specificity, temporality, and coherence. And in Hill's criteria, it is strength, consistency, specificity, temporality, biological gradient, plausibility, coherence, experiment, and analogy. Guidelines for judging whether an association is causal or not. The temporal relationship, strength of association, dose response relationship, replication of the findings, biological possibility, consideration of alternate explanations, cessation of exposures, consistency with other knowledge, and specificity of the association. Now, coming to temporal association, the causal attribute must precede the disadvantage of unfavorable outcome. Exposure to the factor must have occurred before the disease developed. Length of interval between exposure and disease is very important. If the disease develops in period of times too soon after exposure, the causal relationship is called into question. The strength of association. The relationship between causal and outcome could be strong or weak. With increasing levels of exposure to the risk factors as an increase in incidence of diseases is found, and there are statistical methods to quantify the strength of association, that is calculation, relative risk, and attributable risk. Okay. Coming to dose-response relationship, as dose of exposure increases, the risk of disease also increases. If dose-response relationship is present, it is strong evidence of causal relationship. However, the absence of dose-response relationship does not necessarily rule out the causal relationship. In some cases in which a threshold may exist, no disease may develop up to a certain level of exposure, which is the threshold. Above this level, the disease may develop. Now, replication of the findings. If the relationship is causal, we would expect to find it consistently in the different studies and in different population. Replication of findings is particularly important in epidemiology. If an association is observed, we would also expect it to be seen consistently within subgroups of the population and in different populations, unless there is a clear reason to expect different results. Okay, so I'll stop here. We'll continue this chapter in our next class.